This is the third devlog for Project Fire, with this month's focus on playtest polish. The goal is to get the game in a playtest ready state where I can give the game to some friends and make sure everything is working. I want to give a full end-to-end experience, so that means people can pick their starting equipment and slightly customize their character, then play through a level. Probably more than what's needed for initial tests, but I want to have that option. My goal was to get a playtest session by the end of the month, but that plan didn't work out. The reason behind that was because I took a 10-day break to join some friends in a game jam, where we spent a week making essentially Katamari with guns. It was the first time I'd done a game jam, so it was an interesting experience working in a small time frame with a bunch of people. You can check out the game in the description if you want to try it. Back to Project Fire, I started work on the beginning screen where players could select their loadout and customizations. The player can select their starting weapon, their ability, and how they want their character to look like. Each weapon and ability pulls information directly from the asset I made before, so the UI just reads the information. No extra work needed for that other than creating the UI. Speaking of models, my friend helped make 3 models for the game. She's really into pandas, so all the characters are panda based. Each one was created in Magic of Voxel, so I had to run them through Blender and fix the vertices and redo the UV mapping. Magic of Voxel is great for quickly creating voxel art, but the exported models are very inefficient, so some work is needed to make them game ready. You might be wondering, why am I manually redoing the UV maps? Why not bake the textures and just auto-map the UVs? For my test in the game jam, the texture from baking has some artifacts and isn't perfect. Plus, with my UV map, I can easily change the colors of different parts of the model, and the texture size is small. A little bit of extra work is needed up front, but I can get a much cleaner texture file, and it's easier to customize the character model colors. Having customizable player characters posed an issue. How do I sync every client so they display the correct player models? I needed to create a library of all available models and their customization so a player can alert everyone about their loadout and selected model. The easiest way to do this would be to create an asset that holds a list of available objects that can be mapped to some index so the player can send an ID and all clients would know how to load it. It would be easy to manually create the resource file, but updating it every time I add a new model is tedious and error prone, so I need a way to automate this. Luckily, I can create custom menus in Unity that will regenerate the resource files. It can't fully automate it. I still have to activate this menu item, but it's better than manually updating each file. The way this works is by first creating the resource file if it doesn't exist, then searching the Unity asset database for all scriptable objects of a type in the specified asset directory. It will then update their ID based on an array position and add it to the master resource list. The ID is used in network calls to reference when they're syncing data. I made this as general as I could using C# generics and interfaces, so I could add more resources without changing this part, as long as they all use this base item. Audio was already implemented in the game in the first month, but I turned it off while testing since the sound effects and music would get repetitive very fast. I have some test audio files for the sword swings that you can hear in the sample. For background music, I create special assets that have an intro and looping property. I can put these assets into the music player, and events can fade in the music, fade it out, stop, and started, and the player will automatically handle playing an intro if it has one, and transition to a loop without interruption. However, while testing it, I noticed something was wrong. Listen to the sample. What happened there? Even though I had the loop play right after the intro, they somehow overlapped briefly and create this loud spike of noise. The timing was off, but it seemed to only happen if I tried playing music the moment the scene loaded. After a bit of research, I found the problem. It turns out audio timings work differently than frame timings in a game. For example, let's say the game just began, and both the total game time and the audio DSP time is 0. If the game has a frame rate of 60 frames per second, then on every update frame, the total game time would update like this. However, for the audio time, it might look more like this. Note that the times don't match up or update at the same rate. To fix this, I added a coroutine that would detect when the DSP time changed, so it would be synced with the latest audio update and then start the music. It's probably not the most accurate, but it seemed to have fixed the problem, and now it sounds like this. That sounds much better. My schedule should be back to normal next month, so I'll finish the rest of the polish and get a playtest going to see how everything is working or not working. Thanks for watching, and good luck to your game projects.